Hello. On behalf of the APC, I would like to thank you for taking time to learn more about the biosafety of spray-dried plasma and blood products. My name is Louis Russell, and I'm President and CEO of APC. The continued spread of African swine fever in Eastern Europe and into China is causing the global swine industry to reevaluate biosecurity practices in an effort to control the spread of this virus. As a supplier of spray-dried animal plasma, it's important for us to explain the steps we're taking to ensure the biosafety of our product so that you're comfortable continuing to use spray-dried animal plasma. Today, we will briefly review the spread of African swine fever, and then we will review the commercial production process of spray-dried animal plasma, with emphasis on biosafety steps incorporated into the production process. Before we get started, I want to share the results from a trial just completed at CRESA, a Bio-Level 3 disease research facility in Spain. In this trial, African swine fever virus was spiked into liquid plasma and spray-dried to simulate commercial production. The results of the trial demonstrated that the drying process resulted in over a 4-log reduction in infective virus. We'll have more to say about this later in the discussion. First, we will look at the geographic extent of the virus. Reports show that African swine fever continues to spread in Eastern Europe and has reached as far west as Poland, the Czech Republic, and Hungary. In addition, recent reports show that the virus has now moved into China, and the number of reported cases continues to grow. It's obvious that the African swine fever virus is moving, and the global swine industry is becoming very focused on controlling the continued spread of this virus. APC is a leading manufacturer of spray-dried animal plasma. I would like to explain the multiple biosecurity steps included in the production process of spray-dried animal plasma. In 2004, the World Health Organization published a technical report establishing guidelines on viral inactivation and removal procedures intended to ensure the viral safety of human blood plasma products. At APC, we use the WHO recommendations for human plasma products as a guideline to evaluate the production process for spray-dried animal plasma for use in animal feed. The WHO identified 3 complementary approaches during the manufacturing process that contribute to viral safety of blood plasma products. These include donor selection, testing of donation and plasma pools, and viral inactivation procedures in the course of manufacturing. We'll discuss each of these approaches as they apply to the commercial production of spray-dried animal plasma. APC collects blood in federally inspected slaughter facilities from animals that have been inspected and passed as fit for slaughter for human consumption. This precludes collecting blood from clinically sick animals or animals from regions where OIE List A diseases have been reported. Spray-dried animal plasma can be tested depending on customer request and the availability of commercial tests. For example, APC can issue certificates of analysis certifying that the plasma is PCR negative for the EDV. Or PCR testing can be used to certify the source species of plasma. For example, bovine plasma can be certified free of porcine material. APC has invested significant time and resources validating the effectiveness of viral inactivation at critical processing steps. The WHO defines a robust, effective, reliable processing step as one that is capable of inactivating 4 logs or more of virus. The production process should include either 2 robust processing steps able to inactivate envelope viruses, and the steps should be independent and act by different mechanisms. Or The production process should include one robust processing step able to inactivate non-enveloped viruses. Non-enveloped viruses tend to be more stable than enveloped viruses. Therefore, if a process is able to inactivate non-enveloped virus, the process is sufficient to inactivate an enveloped virus. Commercial production of spray-dried animal plasma can include 3 critical processing steps capable of inactivating over 4 logs of enveloped and non-enveloped viruses, including spray drying, UV irradiation, and post-drying heat treatment. First, we will review spray drying. The EU Directive 2002 identifies a minimum temperature of 80 degrees throughout substance as an effective heat treatment to inactivate a number of viruses, including foot and mouth disease, classical swine fever, swine vesicular disease, African swine fever, and rinderpest, and others. APC has conducted a number of tests to validate that commercial spray drying conditions are capable of inactivating a number of viruses, including PRRS, pseudorabies, swine vesicular disease, PEDV, and most recently, African swine fever virus. Consistent with WHO guidelines, commercial spray drying conditions have resulted in 4-log viral inactivation of both enveloped and non-enveloped viruses. These data have been published or are being prepared for publication in respected peer-reviewed scientific journals. One of the more recent technologies APC has introduced is the treatment of liquid plasma with UVC radiation. The WHO recognizes UVC radiation as an effective treatment to inactivate a wide variety of viruses and other microorganisms. APC has conducted a number of trials evaluating the efficacy of UVC radiation to inactivate both enveloped and non-enveloped viruses. In these trials, live virus was spiked into liquid plasma, exposed to UV radiation, and grown in cell culture to determine viral inactivation. Consistent with WHO guidelines, UVC irradiation of liquid plasma resulted in inactivation of 4 logs of both enveloped and non-enveloped viruses. In addition to the spiking trials, a pig bioassay was conducted. In this experiment, commercially collected liquid plasma was treated with 0, 3,000, or 9,000 joules per liter of UVC radiation, and then 10 mils of liquid plasma was injected intraperitoneally into naive pigs. The results of this trial show that pigs injected with liquid plasma not treated with UVC radiation showed signs of infection with various viruses. In contrast, pigs injected with plasma treated with 3,000 or 9,000 joules per liter did not become infected with any pathogen and showed no clinical signs of illness. This data further validates the effectiveness of UV treatment to inactivate potential microbial pathogens. Post-drying heat treatment has been shown to inactivate PEDV. When inoculated onto dry plasma and held at 20 degrees C, PED virus did not survive over 7 days. As a result of this data, APC has installed supplemental heat in insulated warehouses where plasma is held at 20 degrees C for a minimum of 14 days post-drying as an additional safety step to protect the product from post-drying contamination. In addition to validating the specific processing steps, a number of feeding trials have been conducted. In these trials, plasma was inoculated with virus before processing or was PCR positive for virus after processing. In these feeding trials, the pigs did not become infected, further demonstrating the effectiveness of the commercial production process and the safety of spray-dried animal plasma. Finally, plant biosecurity procedures have been reviewed and additional steps have been implemented. For example, incoming liquid is isolated from finished product. Employees are dedicated to wet or dry areas within the plant, including dedicated welfare areas and work zones. Sanitation barriers have been installed when entering controlled areas within the plant. Plant security has been enhanced with strict requirements for visitors, and new UV technology is being installed. To summarize, commercial production of spray-dried animal plasma incorporates the elements identified by the WHO to assure viral safety of human blood plasma products, including donor selection, testing of plasma pools, and viral inactivation procedures, including spray drying to achieve 80 degrees C throughout substance, UV treatment of liquid plasma with a minimum of 3,000 joules per liter, and post-drying heat treatment where product is held at a minimum of 20 degrees C for 14 days after drying. In summary, spray-dried animal plasma is an effective, high-quality feed ingredient that should be confidently used in animal feeding programs. If you need additional information, do not hesitate to contact us. Thank you for your attention.